All right, 7-2 greatest common factors, or in the parentheses, I'm going to write a capital G, capital C, capital F. They do that for greatest common factor. If you took Math 7 last year, this should look familiar, but what this thing is we talked about divisibility in the last section. This is going to be the largest number, two or more numbers are divisible by. So in other words, if you have two or more numbers, what's the biggest number that you can divide them both by and not get a decimal answer? And we have two different ways to do this. This first way is going to be to list all the factors of the two different numbers. And by that, it's kind of like going back to what we were doing yesterday. You could look at it as though it's the rainbow method. That's how some of the lower grades teach it. And then the greatest common factor is going to be the largest one they have in common. So greatest common factor equals the largest number they have in common. So I'm trying to go kind of fast because we did this in Math 7. But if you're getting lost, either rewind the video or ask a question, be glad to help. But if we're doing this with a 24, all right, we could say, well, 24, we could break that up into 1 and 24, and they called it the rainbow because often they connected them this way. So then we also have 2. 2 times what gives me 24? That'd be a 12. So 2 and 12 are connected. 24 divided by 3 works because 2 plus 3 is 6, so you could divide that by 3, and that gives you 8. And then we have a 4 times a 6. 4 and a 6. And you could skip those little lines up above if you want to. I usually don't really like having those in there, but nothing wrong with having that in there. But all those are going to be the factors of 24. All those are the numbers that 24 is divisible by. And we could do the same thing with 40. We could say, all right, 40, maybe switch colors. So 40, we'll make it this aqua-y kind of thing. So that'd be 1 and 40, and 2 and 20. Can't divide by 3, because 4 plus 0 divided by 3 doesn't work. Could divide by 4, gives me 4 and 10. Then 5. 5 times 8 is 40. 6, well, you could divide by 2, can't divide by 3, so 6 won't work. 7, no good rule, but we know it doesn't work by looking at it. And that is it. So that's kind of one problem with doing it this way, is that the numbers are all spread out. Looks kind of hokey, but we have those. Now we could just go through my list and say, well, which ones do they have in common? So if I'm starting over here, I have a 40, a 20, a 10. As I'm doing each one of these, I'm kind of putting my pen over here and looking over here to see if they're the same. So 20, but no 20. 10, but no 10. We have an 8 and an 8. So perfect. 8 then is going to be the greatest common factor. So GCF equals 8. So way number 1 works, but it's kind of a lot of extra work because you're finding a whole bunch of factors that aren't. Where way number 1 is nice is if they're pretty small numbers, then I'll do this. But if they're big numbers or it's kind of a pain, sometimes I can just look at it and know if they're small numbers. It gets a little dangerous if you haven't done math for 40 years. All right, way number 2. Do prime factorization, do the factor tree to both numbers. Then the greatest common factor. To get that, you multiply the prime factors they have in common. Multiply the prime factors they have in common. So this is nice when you have big numbers or when you have multiple numbers, like more than 2. So I have 3 numbers here. So to do this where you're listing all the factors for these would be a seriously exciting thing to, no, just would take a long time. So, all right, so 120, I'm going to break that up into a 2 and a 60. And then I'm going to do a 2 and a 30. And then I'm going to say a 3 and a 10. And then a 10 is 2 times 5. So I have all these for my prime factors. And if you stay organized, you don't really need to circle them. But please, on the quiz in life, it's going to help you if you write 2 times 2 to the third, because I have 2 times 2 times 2, times a 3, times a 5. It's just easier if you write this than to try to go off all those different factor trees. So 216, that might be a little bit dicier than 120. But 216 is even, so I'm going to divide by 2. Half of 200 is a 100. Half of 16 is 8, so it gives me a 108. And then I look at that and I think, ooh, that's 54 times 2. So 2 times a 54. 9 times 6 is 54. So I'm going to do a 9 and a 6. And then my 9 is a 3 times 3. My 6 is a 2 times 3. So you could go through and circle them. I'll maybe circle them as I do them. So let me undo that 3 a second. So this might prove smart. So I'm going to circle them as I use them. So I have 3 2's there, so that's a 2 to the 3rd. Times 3 3's, it's a 3 to the 3rd. So there's my kind of final prime factors for each of those. And last but not least, we have this 168 that's been patiently waiting for us to bludgeon it into submission. So let's see. So I have a 2. So I'm going to look at that as 160 plus 8. So half of 160 is 80. So I have an 8 in the tens. Half of 8 is 4. So we have an 84. All right, 84. That should be 12 and something, right? So 12 and 7. So maybe do 7 and a 12. I suppose a lot of people would probably do like 2 and 42. That would totally work also. 12 is 3 and 4. And then 4 is 2 and 2. All right, so final thing. I have my 3 2's. So that's a 2 to the 3rd. And I only have 1 3, so times 3. And then times 7. All right, so we have this done, but now the question is, what in the world do we do once we have these 3 kind of combinations of numbers right there? So for doing that, we set up above that we multiply the prime factors they have in common. And by that, it's not just, ooh, look, there's a 2 in all of them. But if you look, I have a 2 to the 3rd, a 2 to the 3rd, and a 2 to the 3rd. So each of them have a 2 times 2 times 2. So part of my GCF is going to be a 2 to the 3rd, a 2 times 2 times 2. All right, now if I go with 3's, this just has 1 3. This has 3, 3 times 3 times 3, and this has 1. So what they have in common is just 1 3. All of them have at least 1 3, so we multiply by 1 3. Then, all right, we have a 5. This one doesn't have a 5. You could keep checking if you wanted to, but if they don't all have a 5, we don't do a 5. This is a 7, but these other two don't, neither one has a 7. So then you only do what's in all 3 numbers. So 2 to the 3rd times 3, 2 to the 3rd is 8, times 3 is 24. So greatest common factor is 24. And if we would go through and list all those factors like we did up here in way number 1, that would totally give us the same answer, just would be quite a bit more work. Very last thing, you're going to get some questions in the homework that say, hey, reduce this fraction. And how it applies is you could look at a fraction. So maybe let's say I have 42 over 112. You could find what's the greatest common factor of both of those. That's the biggest number that both are divisible by. So find the greatest common factor and then divide them both just by that greatest common factor. But I have no problem if you just go through and just kind of manually, all right, they're both even, so divide them both by 2, and that would give me 55, 56. And then you can keep going from there. This one's brutal. Can't divide by 3, but you could divide by 7. So that would give you a 3 and an 8. So you could do it like that, or you could just find what's the biggest number you could divide those by and divide them both once. That's all I have. Let me know if you have questions.